Okay, going to be working the homework for 10.4 vectors. Very first problem, we did not cover this, so I'm going to skip it. I'll talk about that in class. Number 2, it says use the vectors in the figure at the right to graph the following vector, v plus w. So we have the vector v here, and we want to add w to it. So all we do is we just slide this one so that the tail of this one attaches to the tip of this one. So when we're done, we should get this vector here moved over to about right there. And that means the resulting vector will start here and end here. So that should be v plus w. Now they're using bold here. For the vectors, we use the little notation like that. So it should be that one. Let's see which of these that is. There's VW. It looks like that one. No, definitely not here. This one is backwards, so it's the wrong direction. And then this one, no, it's not that. So should be this first one. Check that answer. Good. Okay, next one. Use this figure to figure out what 4v is. If this is v, then 4 times v is going to stretch it out, make it 4 times as long. So it's going to look something like this instead. So let's see here. Can't be that one because that one is pointed up. This one's pointed up. This one's pointed down. What are the difference between these two? So how long is this one? The original one was 2 of these, so it should be 8 now. So it can't be that one. I don't know. These look almost the same. What the heck? 2, 4, 6, 8. Maybe they're counting each of these like 2. 2, 4, 6. Okay. 2, 4, 6. That'd be 7. So it's it looks like it's this one here. That's a weird one. Okay, use the vectors to figure out what v minus w is. So here's v, we want to take away w. So minus w means w pointed in the opposite direction. So that's minus w. And so we're going to paste that one, paste the tail of it to the tip of this one, like that. And so the resulting vector will be the vector that goes from here to here. So which of these looks like that? Looking like this one here, v take away w. Here's v take away w, but they have the arrow the wrong direction. It should be going from the tail of this one to the tip of that one. And it's not that one, so it's got to be this. Okay, so use this figure to determine whether the given statement is true. K vector plus g vector is the f vector. I can't make this any bigger. Okay. Well, the k vector is this vector. And then the g vector looks like it's this vector. So they're already tail to tip here. So the resulting vector is going to be a vector that goes from here down to here. But it looks like, I'm gonna clear that out. Looks like f goes from here to here. So it looks like this is not true because it should go from here to here. So it should be the opposite negative f in fact, but we're going to just say that this is false. Okay. Okay, they give us another figure. Figure out if g is b minus c plus h. Oh, great. Okay, good. We can make this one bigger. So here's b. Okay, now we want to do minus c. Now C, it looks like to me that C starts here and goes here like that. So minus C will actually go the other way. So minus C goes like this. That's minus C. So if we take B and we add to it minus C, we're here. And then we do plus H. Now H goes from here to here. So H goes from here to here. So it's already attached tail to tip. So we've got B, we got the tip of B attached to the tail of negative C, and the tip of negative C attached to the tail of H. So the result is right here. So that means that the resulting vector would have started here and ended here, which is what G is. So this looks correct. Okay, same thing here. Can't make it bigger. Okay, F plus E is C plus D. So F is this vector plus E, which is this vector. And it's going to be hard to show here. So let me show you what F plus E is. F goes from here to here, and then E, we're going to attach the tail of E to the tip of there. So that's going to make it look, I don't know, something like this. And so the result, well, how many does it go down? Let me see. I'm going to have to actually count this out. 1. So I'm looking at E. It goes over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It goes down 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 goes down 2. So it should actually end about right here somewhere. Okay, that's F plus E. And now C plus D. So C plus D is C goes here, and then plus D gives us down here. So that would result in a vector that goes like this. And the resulting vector for the other one went like this. So those are definitely not the same. So false. That's hard to do. Okay, so if the magnitude of V is 2, what is 4V? The magnitude of 4V. So all we do is scale it by 4, so it should just be 8. Okay. All right, the vector V has an initial point and terminal point Q. Write V in the form A plus AI plus BJ. That is, find the position vector. Okay, so here we have a point. We have point P, which is the point 8, 0. So here's 8, 0. There's the, so that's the vector. That's the vector that connects. Oh, I'm sorry. Let me start this over. Hold on. They didn't give us vectors. They gave us points. Okay, so we have a point P that's right here. That's the point 8, 0. And then we have Q is the point 0, 1, which is here. That's Q. So the initial point is P and the terminal point is Q. So the vector we're looking at is the vector that goes from P to Q. And remember, Q is the point 0, 1. So to find this vector V, what we do is we take the 0 and subtract 8, we get -8. We take the 1 and subtract 0, we get 1. So that's the vector V. Now it wants us to write this in the form using the I and the J. I showed you that in class. All it is the -8 in front of the I, and then plus the 1 in front of the J. J hat or J or I hat. Now they use just bolded I and J, and that's fine. So we're going to go with, I believe, this one right here. Okay, so now the next one, they want us to find the magnitude of V. So the vector V, I'm going to write it in the way we wrote it in class, is -3, 5. And then the magnitude, they use a double absolute value for magnitude. We used in class just 1 like that. Okay, so it doesn't matter, it gives you the same thing. So all we do is take each of the components and square them and take the square roots. We get square root of 9 plus 25, which equals the square root of 34. So let's see here. Square root 34. This thing's going slow. All right, so they give us 2 vectors here. V is the vector 3, -6, and W is the vector -2, 3. They want us to find 2V plus 3W. So 2 times V is 2 times the vector 3, -6, plus 3 times the vector W is -2, 3. all we do is really kind of distribute the number through here. So we get 6, negative 12, and then we're adding to that the vector negative 6, 9. And now all we do is add the components together. So I do 6, add negative 6 at 0, and then negative 12, add 9, and I get negative 3. So we get the, oh, and they want the form in the, they want the form of the answer in using I hat, J hat. So this is 0 I hat plus, or sorry, minus 3 J hat. So this should just be minus 3 J hat. So minus 3 J, I guess I'm just going to put J. Yeah. Yeah, I took it. Okay. Find the magnitude of V minus W if V is equal to negative 2, 6, W is equal to negative 4, 4. So we need to figure out what V minus W is first. So V minus W will be equal to this vector minus this vector. So we're just going to go negative 2 and take away negative 4. That means negative 2 plus 4, that's 2. And then 6 take away 4 is 2. And that's what V minus W is. And now we need the magnitude of that. So we take the square root of each of the components squared and added together. So we get square root of 4 plus 4. So we get square root of 8. So square root of 8. Whoa, what did I do wrong? I write something down wrong. V negative 2 add 4. 6 take away 4, 2. Square root of, let's see, 2 squared is 4. 4 plus 4 is 8. What the heck? All right, I'm gonna check the answer again because something ain't right. Oh, geez. They wanted me to rationalize, or they wanted me to pull out the 2. All right, whatever. That's so frustrating. I would have taken square root of 8 on the test. That's no big deal. Okay, find the unit vector having the same direction as this one. Okay, so what we do here is we take our original vector, which I'm going to write this way, 24, 10, and we find its magnitude. So the magnitude is square root of 24 squared plus 10 squared, which is, as I get my calculator out, 24 squared is 576 plus 100, which is the square root of 676. Let's see if that's a perfect square. I don't think it is, but maybe it is. Yeah, it is 26. So this is 26. Okay, so now to get the vector that is in the same direction as this, but has a length of 1, what we do is just take that vector and divide each of the components by this length, 26. 10 divided by 26. And then we can reduce those because let's see what goes into both of these. 2, 4, 6. So let me see. 2 goes into that 12 times, 13 times. And then 2 goes in there 5 and then 13 times like that. So it should be, and then they write it in the I hat, J hat way. So I hat plus 5 over 13 J hat. Okay, so which one is that? Looks like this one right here. Okay, on this one, same thing. We want to find a unit vector in the same direction as the vector 1, negative 5. Be careful, the 1 comes from the fact that there's 1 in front of the I. So I find the length of this vector first. Square root of 1 squared plus negative 5 squared. So that's square root of 1 plus 25. That's root 26. So now what I'm going to do is I'm going to take this original vector and divide each of the components by the square root of 26. Negative 5 over the square root of 26. And it looks like they want it again in the I hat, J hat. So minus, because there's a negative there, 5 over root 26J. All right, now hopefully they don't want me to rationalize the denominator there. So 1 over the square root of 26 I minus 5 over the square root of 26 J. Oh, good, it took it. Good. All right. Write the vector in the form. Okay, so we didn't really do this, but I think I can help you with this. I think it'll make sense. So we want to write the vector in the form AI plus BJ, given the magnitude of V and the angle it makes with the positive x-axis. So here's what we know. We have a vector that has an angle of 45 degrees and has a length of 9. So we know it's 9 units long. So what we can do here is we can draw a right triangle, and we can try and figure out how long this side is and how long this side is. Well, let's just call this X and Y. All right, so let's find X first. We know that from what we've studied this semester that cosine of 45 degrees is adjacent, which is the X over the 9, the hypotenuse. And if we multiply both sides by 9, we get X. So we just need to go in a calculator. Cosine of 45 is root 2 over 2. Do they want exact answers? They do. So I'm going to just leave it like this and make this 9 root 2 over 2. That's what X is. Now to get Y, we know that sine of 45 degrees is opposite over hypotenuse. We multiply both sides by 9. We get Y, and sine of 45 degrees is also root 2 over 2. So we get the same answer, 9 root 2 over 2. And that's our Y. So that means we can rewrite this vector as 9 root 2 over 2I plus 9 root 2 over 2J. Let's try it. 9 square root of 2 over 2I plus the fraction 9 square root of 2 over 2J. Oh. All right, good. Then we give us another one here. So we have another vector. It has a magnitude of 18. It makes an angle with positive axis of, or positive x-axis of 120. Let's figure out where we are. So 120 is like 90 is straight up. So 120 is like right here. And now we can do a right triangle again. This is a length here of 18, but I'm going to do this a little different because we're in the second quadrant. We know that this has an X and a Y coordinate, and this we could look at as like the radius, and then we could start doing what we did before. We could say, okay, cosine of 120 by definition is the X over the R, which for us is the X over the 18. And so cosine of 120 should be X over 18, multiply both sides by 18, and that's what X is. Similarly, sine of 120 is the Y coordinate over R, which is 18. So we multiply both sides by 18, and we get what Y is. Now, they want us, okay, so 120 is a common angle. So you should know that 120 degrees, the coordinates here are -1/2 and root 3 over 2. So if we're asked for what cosine of this is, it's the X coordinate. So this is 18 times -1/2 equals X, which means that X is going to be -9. And then sine right here, we get 18 times root 3 over 2, which is going to give us 9 root 3 equals Y. So that's, now I can create the vector using the X first. So that's -9I plus 9 root 3J. Weird, now they give us the I and the J. It's really strange. 9 plus 9 square root of 3J. There we go. Okay, so find the direction angle for this vector. So we have this vector. It's the vector v equals 3, 3. So if we were to look at that vector drawn, we go out to the right 3 and up 3. Here's our vector. And so we want to know what this angle theta is. Now, we can just see it's 45 degrees because we go out the same amount we go up. But if we were to, if it were to not be that case, what we would do is we'd say, okay, this is 3, this is 3. And then we're trying to find this angle. So we know that tangent of that angle is equal to 3 over 3 because it's opposite over adjacent. So that means tangent of theta equals 1. And if we do inverse tangent on both sides of this, we get inverse tangent of 1, which on our calculator would give us 45 degrees. And that verifies what we have here, so, or what we thought from the beginning. So 45 degrees and done. Hopefully next one will be a little different. Yeah, okay, so this one, they give us a vector. They give us a vector. And it's the vector negative 12 root 3. So that's negative means to the left somewhere, okay? And then we go up 12. Okay, so we have this point here. We have a vector that goes from here to here. And that vector is the vector negative 12 root 3, 12. So we are in the second quadrant. So if we're trying to find this angle here, what we can do is, again, use the fact that tangent of theta must be the y coordinate over the x coordinate. And that means tangent theta, I can cancel those 12s and just get 1 over negative root 3. And now, yeah, I guess they, yeah, okay. So now we do inverse tangent on both sides. We have to get our calculators out to do that. I'm going to do the inverse tangent. I'm in degree mode on my calculator. I'm going to do the inverse tangent of 1 divided by the square root of 3, negative square root of 3, sorry. I get negative 30. I get negative 30 degrees. Okay, now we have to be real careful because what that's saying, remember, because we used our tangent, our answers are only going to be in the first or fourth quadrant. So my calculator thinks that we're actually negative 30. It thinks that we're down here at negative 30. But in fact, we're right here. So one way you could figure this angle out right here is the fact that both of these add up to be 180. Okay, or you could say from here to here is 180 and this right here is 30 degrees because these are opposite of each other like this. So I'm just going to do 180, take away 30, and that'll give me 150. So that should be the angle 150 degrees. All right, so on this one, find the direction angle for the following vector. Same story. Let's draw the vector -7, -5. So it's going to be like somewhere over here. It's the vector -7, -5. So I'm going to do tangent of theta is the y coordinate over the x coordinate. And that means that tangent of theta, they're both negative, so I can just go 5/7. That means theta is the inverse tangent of 5/7. So I get my calculator out and I do inverse tangent of 5/7. And I get about 35.54 degrees. Now, again, be careful because the arctangent function doesn't know that we're in the third quadrant here. It thinks we're over here with this angle being 35.54 degrees. So if that's 35.54, that means that this is 35.54. And we want to know what this angle is here to here. So we're going to take 180 and add to it that 35. So we do 180 and we add to it the 35.54. That gives us 215.54. So you have to be careful. Round 1 decimal place. Okay, so 0.5. There we go. All right, now I didn't do one like this, but we'll try it. The child pulls a wagon with a force of 40 pounds. The handle on the wagon makes an angle of 60 degrees with the ground. Express the force in terms of I and J. So what they're saying here is, you know, we have a wagon. I'll make it red. We have a wagon. We have a handle. And the child is pulling this, okay, so that with a force of 40 pounds, and the handle makes an angle of 60 degrees with the ground. So this is 60 degrees. And the child is pulling this handle with a force, and then we can represent that force with a vector. Okay, and the force is 40 pounds, so we can visualize that by making the length of that vector 40. So we have a vector that has a length of 40 and is 60 degrees with the ground like this. And they want us to express this force vector, which they're calling this vector capital F. They want you to write it as something I plus something J. So what we're going to do is what we did before. We're going to kind of imagine that this is a right triangle and that we want to know what X and Y are. And so first thing I do is I say, okay, cosine of 60 degrees must be the adjacent over the hypotenuse, or you could say X over R if you'd like. So that's what X is. And then we can do the same thing to get the Y. Sine of 60 degrees would be the Y over the radius or the hypotenuse. So 40 sine of 60 degrees equals Y. And they want radicals in our answer. So 60 degrees is a common angle. We should know that at 60 degrees, the X coordinate is going to be 1/2 and the Y coordinate is √3/2. So this is really 40 times 1/2. That's what X is. So X is 20. And then here's 40 times √3/2 is Y. So the 40 and the 2 reduce out to be a 20, and then you still have the square root of 3. So that means that the X here is 20 and that the Y there is this. So let me try and type that in. So we have 20 plus 20 square root of 3. There we go. All right, I'm guessing this last one's going to be a little harder. Yeah. Okay, so I did not do this one. I haven't done this one. Yeah, I think we can do this. So we have 2 vectors, okay? They say 2 forces of magnitude of 40 newtons and 70 newtons act. So newtons is a measurement of force. 40 and 70 newtons act on an object at angles of 30 and 40 and -45 degrees. So you've got some object here, right? And we're pulling on it with a vector that goes in this direction. It has a length of 40 and it makes an angle of 30 degrees. And then we're pulling on it also with another force that goes this direction. It has a length of 70 and has an angle of -45 degrees. And they want to know what the resultant force is. That means if we add these 2 vectors together, what do we get? So first thing we need to do to add these 2 vectors together is to get them in their vector form, which means the I and the J, or if you'd like, you can do the angle brackets. So let me focus my attention on this first vector up here. I'm going to break it down. Okay, I'm going to try and find the X and the Y. And we just did a problem like this. So I'm going to use the fact that cosine of 30 degrees is equal to X over the R, okay? And I'm going to use the fact that sine of 30 degrees is equal to the Y over the R, which is 40. So 40 cosine of 30 equals X, 40 sine of 30 equals Y. 30 is a common angle, so this is √3/2. And then over here, sine of 30 is 1/2. So we get Y is 20, and we get that X is going to be 20 √3. So here's what I know about this first vector. We're calling it F1. It is the vector 20 root 3, 20. Okay. Now we do the same thing for the other vector. We know that we could look at this kind of like a triangle, and we could try and find the x and the y. So I know that cosine of negative 45 degrees must be equal to the x over the radius. And I know that the sine of negative 45 degrees must be equal to the y over the 70. And so 70 cosine of negative 45 equals x, and 70 sine of negative 45 equals the y. Now, when you look at negative 45 degrees on your unit circle, that has the coordinates positive root 2 over 2 and negative root 2 over 2 for cosine and sine. So for cosine, I'm going to replace this with 70. Negative root 2 over 2 is x. And then over here, 70, and then positive root 2 over 2 for the y part there, or for sine of negative 45. This becomes negative 35 root 2, because the 70 divided by 2, root 2 is x. And then over here, 35 root 2 is the y. Okay, so here's what I know, is that F2 is the vector negative 35, negative 35 root 2, and the y coordinate is 35 root 2. Wait a minute, I got those backwards. Hold on. Cosine, so I got those backwards. I apologize. This is plus, this is minus. I'll go fix it. Hold on. Okay, come back over here. Cosine of negative 45 is the positive one. I don't know why I put that there. And then sine of negative 45 is the negative one. So that's negative there. Okay. So now what we want to do is we want to find the resultant vector, which means add these two together. So if I add those, that's easy to do because I just add their components. So I'm going to do 20 root 3, add to it 35 root 2, and then 20 plus, but we have a negative 35 root 2. So I just added those and added those. And unfortunately, we can't put these together because they're not like radicals. So I think my answer is going to be pretty ugly here. Uh-oh, I've got to close this. Okay, so it should be 20 square root of 3 plus 35 square root of 2, and then 20 minus 35 square root of 2. There it is. And that completes it. Okay, hope that helps.